Hi, my name is Sheila Dyas. I'll be presenting the presentation after lunch, so you'll get more of a spiel about me at that time. At this time, I'd like to present on behalf of Dr. Goldston. I consider it an honor, and kinda, having to get up here and do a presentation is not fun for most people, and so I'm not sure it's an honor, but I'm appreciative of the fact that he thinks I can handle it. We will be talking about data analysis to support healthcare decisions. This was set up as a presentation to discuss what steps you should be taking in the healthcare in looking at data and why we would want to look at it from that standpoint. First, I'd like to point out that Dr. Goldston's name is on top here. I don't know if everyone gets these presentations or the video, but his phone number is on there. So any questions I can't answer, it's there. You can contact him, and I'm sure he can explain it well. It's also included another professor at University of Alabama in Huntsville, as well as myself. You'll see that I have two. I'm also with the Industrial Engineering Department at the University of Alabama in Huntsville as a student. So I'm in the doctoral program, but I work at Huntsville Hospital. We had two doctors there that were also part of the team that are part of the emergency department, the vice president of emergency services at the hospital, and then the other industrial engineer. There's only two of us in this hospital system, who is mainly over the hospital itself, and where I'm over the emergency department. To give a little background about how this process started up with UAH. It was a collaboration between nursing and industrial engineering. There's a large nursing school at the University of Alabama in Huntsville. And so working together with the industrial engineering department, they started branching out to the healthcare industry around us to come up with different ways that we can incorporate industrial engineering into the processes they were using there. This was a great benefit to students and allowed them hands-on training in an up-and-coming area, specifically in industrial engineering, more of the healthcare management side of it, and then for nursing themselves to have an understanding of the industrial side of it. So when they went on board, that they knew about all their Kaizen events and their waste management that they were going to have to deal with. And then from the faculty standpoint, that gave them the opportunity for new research activities. So every time we were to discover an issue within the healthcare environment and worked on a solution for it, that created an academic paper. And then it set up students and employment opportunities on one of those. I ended up working for the hospital, which I'd done some of the research for. And then, of course, setting up contracts for training and issues of that item with the university itself. So with Huntsville Hospital, we started that partnership in 2012. And it was initial partnership with the Industrial and Systems Engineering Department at UAH with the emergency department, not with the hospital itself. It has branched out. Now they are conducting training within Lean and Six Sigma within the hospital, other areas within the hospital. They've also done simulations of the critical care units as part of the work they're doing. And just recently we've been doing a nurse staffing model development and inventory analysis. So in the process of looking at all the activities that go on within the hospital itself, we discovered that the majority of it is more of a reactive system monitoring. We have a problem, it shows up, we have to go and do something about it, and we consume resources, and everyone waits for the solution. And in the emergency department, that basically causes backlog. So what we felt like would be a better way of handling it is a proactive approach. So to do a proactive approach, we have to take it more from the standpoint, we need an understanding of the current system. We need to be able to alert decision makers to those problems. We need to have an awareness of building those relationships of all the other entities within the hospital. And then we need to have that information and provide the further analysis to go to the next step. So right now, This is an example of the dashboard. I don't know if y'all are familiar with dashboard terminology. Okay, good. So from this dashboard standpoint, there's a lot of information on here. And if we were to look at this dashboard on a regular basis, we would probably ignore most of it. It doesn't have flashing lights. It doesn't tell us that there's something wrong. It just gives us information, and we're supposed to use our past experience and say, okay, this information's off. So from this current system, there's no really good assessment of what the performance is doing. You know, how's it doing? Okay, this is great. This isn't. Is it good? Is it bad? There's no warning device. There's concerns about data integrity. Most of the information systems that are set up for healthcare are devised along the item of liability. So there are timestamps, there are information to say what happened and when it happened and record it so that if something happens in the future, there's a problem that occurs, that you have documentation about patient care. It is not set up for us to be able to measure our Six Sigma performance. It is human input. It is timestamps that are based on going to a computer and recording it. And in addition to that, a lot of times they batch them together. It's not as it's occurring. So there's a lot of concerns with the data integrity from an industrial engineering standpoint. The reports are run after the fact. They're not ongoing. It's not real time. It's very difficult to get real time because of the stops and starts associated in the data information system. A physician in the emergency department is going to move on to the next patient before he necessarily closes out on the first one. It's not like a series process. There's a lot going on. He may wait till after he's done with his whole shift to close out his reports. So did that mean the patient stayed on the bed that whole time? No. So there's a lot of issues as to exactly what you want to monitor. So this is obvious from our standpoint. If we want to get good data that would be useful, that we need to modify this in some way. So we're looking at analysis of this. We've got certain lengths of stay, which LOS is standing for up there, that we want to try and control. We want the patient to get in and out as quick as possible. We've established goals for ourselves, whether they're realistic or not is anyone's guess. We're, at this point in time, not meeting them. But they are something to shoot for and to work at. And the questions that we need to understand is what are those key process indicators that we need to monitor? I mean, do we need that entire dashboard to be able to understand what's necessary to meet these goals? And then what type of relationships are there? You know, are there, do we need to understand what's going on with the patients? Do we need to understand the flow of the staff? Do we need to understand exactly what the flow of all the other departments are that provide support services to the emergency department? So in doing a factor analysis just based on that dashboard itself, we can see that there are relationships between items on the dashboard. Well, some of them are obvious. They're direct relations to each other mathematically, so they're going to be related to on a factor analysis. Then why are they all on the dashboard? So ideally, if we look at this, we could, in essence, have just 5 items on the dashboard instead of the 20 that we do. So, that in itself is a simplification stamp. This is just an overview of what we could do, where you could take this to. This is not by any stretch of the analysis that says this is all we would do. This is saying that if we take the information that's there, get an understanding of how it correlates to one another, work together to come up with something that's meaningful at all levels so that we understand exactly what each one of these factors presents to the other factor, then we can do a better job at controlling the effectiveness, the patient care, and the efficiency of our operations. So if we look for suggestions as to exactly how we would want to do the data monitoring, you'll notice on there in the parentheses, Dr. Goldston has put proactive versus reactive. And we want to go more towards something that is proactive. This way we can stop the problems from occurring instead of waiting until after they already have and try and resolve the issue at that time. You know, there's not a lot of time in that length of stay. You know, you've got 180 minutes to resolve a situation. I don't think it's going to happen that way. So instead, you know, you want to set up something so as before those patients get there, you've got this problem solved. And so if we look at the queuing, and we're going to monitor arrival rates, monitor staffing levels, and maybe at that point we can determine where we're going to have a situation, and we can come up with a mitigation strategy before the situation occurs. Where if we look at factor 2 and factor 3 and factor 4 as well as 5, where we're looking at timing the systems, the LWBS, and that's left without being seen. So they came into the emergency department, a physician was not able to see them before they left. They got tired of waiting, basically. And admits, you know, how many patients are admitted. And there's all sorts of issues with admits in the hospital because now you've got 2 bed systems being operated independently. And the tie of those together is not easily accomplished. So, you know, operating those in unison is difficult. And then the last finder, seen in 30 minutes. So if we're monitoring these actual data, you know, we know them after the fact. You know, when they left without being seen, they've already left. You know, there's nothing we could do to stop that. So we need to take these last 4 factors. We've narrowed it down to 5, but we need to take these last 4 and make them more proactive. We need to come up with a way to see that this is happening and expect it to occur and mitigation strategies to keep it from happening. I mean, if we're anticipating because of our wait times, for instance, that we're going to start having left without being seen, then we're going to have a higher volume of those, then maybe we can come up with some sort of method to keep them from leaving us readily. A different holding area, a different setup, a more interaction of vital signs, something of that nature that keeps them from leaving. So, you know, we could be more proactive on having that happen then. So, you know, from a proposed data infrastructure, you know, we know what is happening. You know, we've got the dashboard. Our data is only to a certain level accurate, but it's well enough to describe the system. But that's definitely reactive. But we have that. That's most hospitals, I would say, have that. You know, that's something. The next item is knowledge, and this is where industrial engineering comes in. I know that industrial engineers are not knowledgeable about medical processes, but they are knowledgeable about the root causes behind why we're having these problems. They can go through the step analysis and do the fault trees. They can take all that tools that we've learned and come up with the actual steps that we want to take to resolve these situations. So once we have that knowledge, then we can be predictive. We can find those areas that are going to tell us what was wrong and why it occurred the way it did. And then, of course, the last item is optimization. Now that we know what we're doing, you know, so, which in the healthcare industry is quite a task, we can take that information and optimize our systems, come up with the best process that's going to work. So I guess I've already talked about that one. In summary, improved data collection is needed. We need to feel comfortable with our data. Last, data formatting to reduce the need for major reformatting activities. So we need to set that up so we can see that dashboard, know what we're doing, and be able to utilize it. And then once those data systems are set up and we can get what we need from them, then we can start the analysis and go through those root causes and set up that process. So. Questions? I know in the program it says University of Alabama at Huntsville. I need to put up a plug now for Huntsville Hospital. They are who funded me to come here. And they are a system that is growing with all the different environments that are going on. And so I want to represent them properly here. You'll notice up here that the title on my presentation is not the title in your handout. It's Data-Driven Process Improvement in the Emergency Department. However, one of the things I've discovered being an industrial engineer going into the medical area is that engineering ease is not there. we're talking more about even patient care. If I'm going to improve the process, I'm going to improve patient care. And that's not really what an industrial engineer is doing. They're going there to improve the process to make it more cost effective, make it more efficient. And we can't quite do that without looking at money. So what we want to do is focus on increasing the profit. And that takes more of an inroad. It makes a bigger statement at those companies that you're dealing with, at those hospitals, at those healthcare entities, than saying, I'm going to make things work smoother, I'm going to eliminate your waste. It just doesn't have the same sort of connotation. So I wanted to point that out that here is that why would they spend the time or the effort and the money on doing a data analysis, a complex data analysis, if they weren't going to increase the profit? So let's see if we can increase the profit in doing that. First of all, to give a little bit of an overview of Huntsville Hospital, they are the second largest in Alabama, and they are a regional referral center for the northern part of the state. But I think the biggest situation with them is that they are the fifth largest in the nation publicly owned health system. So it's more than just this one hospital that we're talking about. So what I'm starting here will go on into a very complex organization. But within the main facility, we're looking at 50 physicians, 250 nurses. It's a state-designated Level 1 trauma center, so we have a high percentage of critical care patients that come into our almost 100,000 patients per year just at the main facility. So my objective of this is to take the data that's provided at Huntsville Hospital and to see if we can identify ways to generate more revenue or decrease our costs. And once again, we're back to that profit. Those are the items of profit. Many of y'all are familiar with Kaizen events. And in my case, I'm going to call them profit grabbers. Because Kaizen events, everyone looks at me like I'm strange when I say that in the medical community. So if we think profit grabber, that catches on and it works a little bit better, easier for them to understand. And once again, we're focusing on increasing revenue and decreasing cost. So if we start off and just look at the data, first of all, if we use the WellSoft, information system, there are several out there. This one's specifically designed for the emergency department. Which is a big difference. If you have an information system designed for a hospital, then it's going to be set up with different caveats as far as reporting and systems of nature. This one's specifically designed for the emergency department, and they're not branching out or expanding. They want to stay focused on the emergency department. The data I looked at was a year's worth of data, and included in that data was almost 90,000 patients. And the outliers in medical care is kind of a misnomer. Those are true occurrences that are in Medicare in most cases. Some of them are data errors. But if it is a true occurrence, are they truly an outlier? Or are they something we should consider? But to make it to where we could make more meaning out of the data, we did designate what certain outliers were in this case. What I've shown up here is what I call a spaghetti diagram. Everyone's informed me that's not what it really is, but that's what it'll end up looking like before we get through this presentation. But in going through the steps here, we had the ideal situation. The green path is shown up here. Patient would come in, whether it be emergency services or via the lobby, and they would go directly to their care center, whether it be, in this case, a Q-Track, and I'll talk more about that, or it be the emergency department itself. They would go there, be cared for, and then if they needed further observation and with the attempt of not getting them to the hospital, they could go to the observation unit, or they would end up at the hospital, or they would be discharged home. And so that would be ideal. We don't have any stops, we don't have any waste, and everything. This is wonderful. However, in the typical situation, we have a triage area. Now, there's a lot of articles out about eliminating the triage area, and you can see why. It's a step. What value does it add in a case? You should be able to do the same effort within the ED itself. But it is a standard process in the step. In addition to that, a lot of facilities have to have transfers. You're going to send them somewhere else, like anyone who's a VA has to end up at a VA facility. So in doing that sort of transfers, that's another step that has to be done. It's not something that you would classify as waste. But then we can add the waste. In the typical situation, we're going to have a lobby wait. We're going to have a bed wait where you're in the lobby waiting on that bed. So you've been triaged and they know you need a bed and they know where you need to go, but there's not one available. So you have to wait. And then the final wait is the bed hold, and that's where you've had all your processing done within the ED, all your medical care has been done, and you're hanging on that bed, waiting on a bed in the hospital, or waiting for your final treatment or your prescription so you can leave. And then from the worst case would be the revenue lost, and those that are leave without being seen. So there's the dollars associated with their care that just went out the door. You have the elopements, those that have been kind of seen but not completed. So you don't have their care completed, and those dollars went out the door as well. And the last one is left against medical advice. And those are not necessarily a cost reduction on your part unless they would have been omitted. But it is, overall, if you have a lot of that going on, there must be something wrong within the system itself, and it affects reputations of doctors and physicians. So it does have a negative effect as well. So now we're up to the spaghetti diagram. We have, the lines everywhere. It does necessarily look like spaghetti. But this is the process that you're going to look at and you're going to evaluate. You can see it's quite complex. It's not something that we easily break down. And each one of those lines represents a line of human variability, not process variability, but human variability. So to look at it from a standpoint of profit, we're going to break it down from the revenue centers. So let's see what we can do in each revenue center to increase that profit. So I've highlighted the 3 revenue centers. Those would be the Q track, and the Q track is defined as a fast track in some hospital systems. It's where the patient comes in, they're truly not emergency care. They probably could have been better serviced at the physician's office or a clinic, but for financial reasons or for just the time of day reasons, they're at the emergency room. And then, of course, we have the emergency department itself and the observation unit. So starting with the Q track, in breaking down the data, we can see how we looked at it here. We've got the standard process. We have the Q track itself. We have incomplete service, and those were all the red ones that I looked at, pointed out as revenue lost. And then we have disposition errors. So there are information that I cannot include in this analysis. And so from the Q track, it only operates a certain time period. It's only patients that come in through the lobby are going to go through the Q track itself. So that reduces the numbers down from that standpoint. I've broken it out by patients that end up being admitted or discharged, and you'll see by there on the numbers in themselves that whether you're an admitted or a discharged patient makes a big difference. And then took it further that once you've gone through the process in Q-Track is whether you were admitted directly from the triage area, which is where Q-Track takes place, or if you ended up having to go into the ER and have a bed on top of that. So you can see there's lots of different steps within this process that we'll be looking at. So the first item to point out here is that there was a 4% reduction in time for the admitted patients compared to the standard process, but there's a 49% reduction for the discharged patients. So obviously this is something good. We want to do more of this with patients that are going to be discharged out of the hospital, 49% reduction in their time. So we took those minutes, down from 246 to 125 minutes. So that's something to think about there. Then in addition to that, when we had the Q-Track operating, as compared to when we didn't have the Q-Track operating, we were better able to focus on our admitted patients and actually had a 5% reduction in the time it took in processing them. So we were better able to assess them, deal with their situations, get them on a bed. The negative that came out of this is we saw an increase. If a patient was ultimately discharged, but ended up having to go on to a bed in the ER itself as compared to just the triage area, then we're doubled our physician coverage. So we're doubling, we're adding that time in there. So we did see a 5% increase. So from this, we can say, okay, if we can reduce the time that much, then we definitely have a profit grabber situation. So we optimize and expand this Q-Track, we can grab more profit. So we looked at first an MLP instead of a physician-in-triage. I don't know how many of y'all are familiar with a mid-level provider as compared to a physician. They are a higher certified nurse practitioner, some of that level that within the United States, they can perform certain services that a physician can perform. And so your lower acuity patients can be serviced strictly by a mid-level provider with physician review. Huntsville Hospital is different than a lot of hospitals. They require that a physician see every patient. So even though we have a mid-level provider, all they're doing is assisting in the process. But the mid-level provider is at least 1/5 of the cost of a physician. And so there's definitely cost savings that can be obtained in using a mid-level provider. We expanded it to 2 rooms, 7 days a week, where it was just 1 room, 5 days a week. We did, because of being a mid-level provider, we limited it to just acuity 4 or 5 patients, and that's using the emergency service index. I know there's all different triage scales. That's the one that we're using. And then we had separate processes set up for patients that were at that acuity level but did require a bed or required a procedure. That doesn't necessarily mean they're going to be fast, but it means they have to go through different processes to be handled. So from this, we saw a significant reduction in provider costs. So we're meeting that goal of reducing our costs. However, we had 35% less patients go through Q-Track, because we've limited it to just 4 or 5 acuity patients. And we added that step in the process of the physician discharge now, where before the physician would do it all as their process, we added this new step. So we did, even though we're making more money, we didn't necessarily help our situation. We're still a little bit better off. 49% was what we saved, but we've increased it back up 48%, so 1% savings. So it's now a good starting point. We've definitely reduced our costs, which, as I pointed earlier, is a main driver in our situation. But our next step will be to take this up to what I call fast acuity 3 patients. Fast not meaning that it's fast for the patient, fast for the physician. So the physician's not going to need to spend a lot of time with this patient, so the MLP can better manage them. And so if we expand that, we can take the number of patients up in that main and still take advantage of these cost savings. So the next one I want to go to is the observation unit. Is everyone familiar with an observation unit? It's not a common thing in the United States. It is something that Huntsville Hospital set up a while back with the intention of reducing the number of patients that ended up being admitted unnecessarily. There were patients that just needed a lengthy treatment or needed to be observed to just make sure they were stable enough to go back in their care. As the population ages, that we have a lot more of those cases. I mean, they're coming in, they have all sorts of conditions, and ideally they could have continual care in a hospital. They have enough conditions at stake, but the hospital is not there to be the nursing home. So instead, we have to get them into a stable condition and be able to send them back to where they were at. So an observation unit allows that to happen. From a revenue standpoint, a lot of those patients are limited funds. So the hospital is not going to be receiving payment for their care. And so in the observation unit, they can get the appropriate treatment and they can get service better. And then from a doctor's standpoint, a cardiologist, this way he can deal with his patient at any hour, at any moment, because it's right next, it's part of the emergency department, just like a cardiologist would have to respond instantaneously to a situation there. They can handle better care in the observation of those cardiac patients as compared to sending them up onto a floor that's spread out all over the hospital and only seeing them that one time during their rounds. This way they can see them at intervals that make sense and they can get them out of there quicker. So that describes the observation unit. In this analysis, we had 2,038 patients go through it. It started in Yeah. It had started in November of this time frame, and there was 71.5% of their length of stay was in GPOT or in the observation unit. So that's where the bulk of the stay is spent. The observation unit consists of 12 staff beds, but there were 16 available beds. So it still was expanding. It was trying to grow. And as you can see on there, we've got the median time that was spent by the patients in that area. So if we take all those numbers and the time period.
Oh, I'm not sure I've heard you right. You say that's the median time?
Yes, it is.
It is the median.
Yes. And I'll explain that in just a minute. If we take those numbers on there, you can see that we're only using 32% of the staff and 24% of our bed capacity. Well, you know, that's not a very profitable situation right there. And this was something that has been going on within this system for quite a while. And to point out this data to individuals, it was kind of a, you know, let's put on some light bulbs there. We use the median because of those outliers. And when we have so many outliers, and they're always on the long side of it, that it skews the average. The median is a better reflection of the bulk of individuals that are there within the process. So if you're going to pick one number over the other to understand the general population, the median works better. If you want to design a process, you may use like the upper quartile or something of that nature to better reflect the care for those outliers.
So you're saying that the data that you have there would not fit to a normal distribution?
No, and you'll see that near the end. So from doing this, you know, we also look further at that. You know, the median patient spent 4 of those hours in the ED. Well, that's 4 hours in the ED. We could have taken that patient and put another patient on there. So they should have been moved sooner to the observation unit. And second, that the treatment-only patients that are up there that are, you know, in your 11,000 as compared to 2,000 number, that you know, roughly 20% of them were spending a greater time on a bed in the ED than the minimum patient was spending in the observation unit. So, you know, that's saying that there's a lot of people that we could have put into the observation unit. So this is presenting itself as another profit grabber, and in doing that, we went to implementing a pull versus a push system. So I mean, most people are familiar with that. The hospital didn't realize that that's what it was described as. But to go through and utilize case managers to go out to the ED and say, okay, these are patients that can be in this observation unit. So in doing that, we went up to 91% staff utilization and 68% bed utilization. So our next step will be to increase the staff here. The next area is the ED itself. It's a more complex system. So I broke it down into the lobby wait, the triage, the bed wait, the ED, and the bed hold area. It was a good way to break it down from an industrial engineering standpoint. I'm not concerned about what's going on in patient care or treatment at this point. I'm more concerned about the flow and the movement of the patients through the system. And then I can take this and break it down even further. I can say which area they went through, whether they were admitted or discharged, if they were in complete service. And we can look at all those numbers and how it breaks down. So I have those that were straight back, those that went through the lobby. And it gives you a different perspective of what's going on with this information. Most people are familiar with the item of bed boarding. And in bed boarding is where a patient is held in the ED waiting on a hospital bed. And that can take a good length of time. As you can see, the bed boarding alone on median time frame is 175 minutes at the Huntsville Hospital. So that's a good length of stay that you're just hanging out in the ED waiting on a bed. Now, but if you go on into here, you can look at it further over, and we look at the bed wait. And this is where you've come into the lobby and you're waiting on a bed in the ED. were 23 minutes if you're admitted and 47 minutes if you're ultimately discharged. Well, so we know what's going to happen to them before they even get onto the bed. So there should be a way in which we can take this information, early indicators of patient disposition, to reduce the amount of boarding that we have. So there's a separate process for anticipated admission versus discharges would be our next profit grabber. This one's under construction. This is a hospital-wide integrated system, and that's a more complex situation. In addition to that, we need to do the data analysis to identify the errors associated, the impacts associated with errors that could occur in deciding whether someone would be admitted or discharged. So there's some more work to do in this area. And then finally, you need to get the most out of your simulation. Now, these are distribution layouts for each of those steps, the top being admits and the bottom being discharged. And so you can see the distributions themselves are quite different. If you're setting up a simulation, you need to also understand that the bed hold, which you consider a weight, is something that has to be designed into your ED process because it's a controlling factor of the ED itself, as compared to where bed weight and lobby weight should come out of the simulation based on your other situations in there. But if you don't set up separate processes for admissions and discharged patients, then you're running the risk of having your simulation be invalid. So you want key variables, proper distributions, and how to handle your outliers. And doing the data analysis allow you to do this. So in closing, the price of light is less than the cost of darkness. So if you can, take this data analysis and open up your eyes, at least it did at Huntsville Hospital, as to a lot of the things that were going on within their emergency department that they had control over that they could fix. So.